Good morning, friends. Today we will see multi-body dynamics using MotionView MotionSolve. So MotionView is a preprocessor and MotionSolve is the dynamic solver, which we are going to use here to perform the multi-body dynamics or vehicle dynamics events to perform the to check the performance of the vehicle. So how we are going to build those models here, that we are going to see today. And while explaining or while demonstrating those models, if you have any difficulty, you can raise your hand and ask question, or in the message chat box. We will try to answer those. If not, if we won't cover those questions today, we will take those questions offline and we will answer those down the line. If you have any specific requirements to understand, you just post those questions on the chat box that we will try to address over this webinar. So how to access MotionView MotionSolve? I guess you are all aware of it, but just give you an idea through the installation directory where you can see this MotionView icon, which you can click and you will see this MotionView GUI. You see this area which is selected in the cyan color window, which is called the MotionView graphical area. Left hand side you see where session, projects, objects, model, that is called the browser area. And once I select anything in the browser, things will pop up in the panel. So bottom below the graphical user interface, you see that area is called the panel, where I will see any points, detail information about points, about bodies, any entity which we use to build the model. The details of that entities we will see in the panel area. So to create any points, I will just go to the points and then create point. So once I create points, you have to define the coordinates of the points x, y, z, and you can keep their orientation as per the input coordinates. Then if you want to create body, right click on the body and say define your label variable name, then create that body, where you have to define mass and inertia as detail. If you already have a CAD model, you can directly import that CAD and you don't need to define these all properties. It will taken care while importing the CAD files. If you don't have a CAD, you just have hard points, then you need to define their mass and inertia property, then CG location, where CG lies of that component or the body or the pod, and then if there is any specific orientation, if those are not in the orientations of the global system, then that also you have to define. So this is how you can create points bodies in the MotionView environment. There are certain more of the entities to define the modeling constraints. Those might be, I am assuming you are aware of. If you are not, please type those in the questions. I can address those. If not, then we will move to the directly to the suspension modeling and how to use suspension models in MotionView environment and how to predict results. That will start addressing those. I'll wait here for a moment to see if you have any questions. If not, then we'll start to the suspension modeling and the basics of suspension, which we address through this vehicle dynamic study. You all are aware of the tool, how to use the tool, and how to create bodies, how to edit them. So we are not spending time over here. We will go to the next thing, which is related to the suspension modeling. So I hope you might already have the details of suspension templates which we have built for Supra event for a half car. These PDFs will help you to build the suspension model. Also, it will help you to modify those models as per the your vehicle configuration. So in general, what is the use of multibody dynamics is mainly it is a wherever the scenario occurs with the large displacements, those scenarios we captured through multibody dynamics. And in vehicle component system, when you would like to, when you are interested to study the suspension systems, steering systems, braking systems, and overall behavior of your system with your physical inputs of springs and constraint inputs, hardpoint locations. Once you build that virtual model, you would like to understand how your vehicle is behaving. So those configuration we will build here, and we will observe the vehicle behavior. To perform those, you have to follow some steps, some procedures to build that. So for that purpose, we have this car user guide PDF file, which is already uploaded on the our website. From there, you can easily download and study them. And while performing those or while understanding them, if you find any difficulty to understand, you can send us an email and we will address your queries. So in half car model, generally what we cover is the suspension, steering, front suspension, rear suspension, steering, and drive shaft if the wheels are driven case. If not, then we will consider the test rig simulations for the suspension, and we'll understand the behavior of the suspension. Like if I'm doing if you are interested to perform the KNC simulation of suspension, then you will have to excite your wheels by some magnitude which you feel in the ground. Those are the magnitudes which are which you want to observe the behavior of the vehicle while performing the suspension study. So that kind of setup we are going to build in the MotionView environment, and we will study that. So how to deal with MotionView to build those models. So in this case, I already have those models. So I'm going to show you how you can refer those models and perform the simulation. So I'm going to open that one of the suspension model which I have for a Supra event. I'm going to open the front half car model. So this is my front half car model, which has a front SLA suspension. I think SLA is a short long arm suspension we are using. You might have some different kind of suspension, so you can try. You can change this configuration with your suspension inputs. So how to change that configuration of the system, or how to change if you are having same configuration of system, then how you can change the hard points to build your vehicle. So we have if you click on the front suspension system, you will see there is a vehicle input data parameters. From there, you can modify these data points. Like your half track weight might be different, then spindle length might be different, then your upper ball joint locations, lower ball joint locations, wheel center, lower control arm bushing locations. These are the coordinates which or this is the configuration of the vehicle which you can easily modify in the design data sets, and this will help you to build your own vehicle configuration. So this is quite easy to change the parameters and build your own vehicle. If you have any doubt here, just let me know. We can discuss more over here. Earlier, how to change the vehicle input parameters to configure the your system. So if you go to the data points and change those parameters, then it will be modified. It will modify those parameters, and you will have your own configuration of the vehicle. And then the spring properties, which are very important, how we are defining those spring properties and preloads of the spring, which is very important, because changing those parameters, those are crucial parameters which will change the behavior of your system. So that also you have to modify. And to modify those parameters, it is quite easy. You can go to the front coil spring system, and then change the properties, the stiffness values, damping, preload values, your free length. Those can be easily modified and can be built as per your configuration. So this is about changing the hard point locations, then spring parameters, then shock absorber. Shock absorber also you can change the damper parameters. If you have damping, if you have any non-linear curves for your dampers, I hope it is quite challenging at this in this stage to have those nonlinear properties, but yes, if you can define those also here. If not, then definitely linear range properties will help you to understand the behavior of the system. That also you can define. There also you can change the parameters to specify your coordinates. You just need to go through those points to modify those coordinates, and mainly these all things will be modified in the vehicle input parameters. If some of them are not available, you can directly go to those entities and modify it locally in those particular members of your model. And then once you build this model, so this is one way to build the model, which I already have one of the model. Apart from this, if you don't find the model which is suitable to your configuration of the vehicle, then what you can do, we'll have uploaded this individual systems of the vehicle, which is like steering system. We have uploaded on the web, which you can individually bring into the MotionView environment and build the vehicle. We have suspension, we have push rod and pull rod type of suspension already built as a subsystem to build the vehicle configuration. We have tires. We are using FIALA tires and vertical spring tires. This is again very important and element in the vehicle, which is always in the contact with the ground and which transfer the forces to the vehicle. So for that, we also have addressed some of the basic study in the vehicle dynamics through the multi-body dynamics PDF, which will explain you how the tires and rubbers, some kind of phenomena behind the using those elements in the vehicle and their effect of those elements on the vehicle while performing the simulation. So those are, I hope you will study through the PDF to understand the vehicle behavior. If you have any doubts here, you can ask me. We will address those right away. So where we are explaining about the tire contact patch. So how tire contact patch is important to have the stable vehicle or the stable suspension, the stable behavior of the vehicle on the ground, and how that provides the reactions to the vehicle, because that is the element apart from the aerodynamics, which is the tire is an element which is always in contact, with the ground, which transfer the forces to the vehicle. And for that, general idea is to understand this friction circle phenomena, which depends on the longitudinal forces as well as the lateral forces. So that phenomena also we are explaining over here, which will give you an fair enough idea idea about how this tire contact patch will help you to understand the vehicle behavior. And then we are also explain here the phenomena of understanding the vehicle handlings, because which is important in your case to understand the understeer, oversteer phenomena of the vehicle. Then we are also explaining here the wheel alignment and the causes of wheel, the effect of wheel alignment on the vehicle. Then general terminologies of suspension system, which are caster, camber. I hope you are understanding all these terminologies, so I'm not explaining elaborately over here. If you feel you have some doubts, you can ask me. So caster, camber, what is mean by camber, what is mean by toe, and what is mean by caster. Those are general terminologies which we have to understand, which we have to observe while performing this simulation. So generally camber is nothing but your angle which is made with the vertical axis of the vehicle or the tire, and toe is nothing but the angle which is made at the longitudinal axis of the vehicle. Similarly, caster angle is the angle which is at the vertical axis of the vehicle, which we see from the side view. So these are general terminologies which we have to observe while performing this vehicle or the suspension behavior. Then what is the effect of camber angle on the contact patch? Then what is the significance of wheel alignment on the vehicle? So these are all overall study which we will observe in the suspension study, and we have readily available those outputs in the our standard report templates also, which will also help you to understand your configuration vehicle behavior once we build these models. And then we have also given phenomena of instantaneous center, which will help you to understand the behavior of your suspension and how to fine-tune your suspension to understand this instantaneous circle phenomena also. So you can refer these documents which we already have on the website to download for you. So we okay. So we were in the modeling of this front suspension. Yeah. So yeah, someone has asked the question like how to get those PDFs. So those PDFs are already explained. Those PDFs are already available on our tutorial. So you can get it from there, or you can send us an email, which we have already given in the chat box. Or you can send an email to the edu support@india.altair.com. We will provide you those details, and then referring those, you can perform those simulations. So in this default template models or the default half car models, what we have is the front SLA suspension. Using that, what type of simulation we are performing? So here we are performing a single wheel analysis. So what does this single wheel analysis do? So let us run this. To run this model, we have to click on the run panel, run button, and then you have to hit on the run. Before, if you are using 12 version, so you have to save this file as an XML, Supra, whatever the name you would like to give, you just give that as a solver file name, and then hit on the run button. So here we have added a couple of events. So in this case, I am running only the single wheel analysis, but you see there are other events also which are already available for you. You just need to activate them. Once you activate any other event, the previous one will get deactivated. So in this event list, those are the multiple events which we have already added, which are necessary to perform on the vehicle to understand your vehicle behavior. So those are already available. If I activate this kinematic and compliance, then the other one, which is single wheel analysis, which will get deactivated, which and then I can perform the kinematics and compliance analysis also, which will help me to understand my vehicle behavior in terms of if I'm applying some vehicle vertical displacement with respect to the vertical wheel displacement, how much how much my toe caster camber behavior and caster kingpin inclination, scrub radius, then wheel vertical forces. So I'll observe those behavior of the vehicle while performing these events. So as I said, I run this model, and now my model has run completed. Now I can go to the run tab and say animate. So once I hit on animate, I can observe the behavior of the suspension. So this is single wheel analysis where I have applied the excitations to the one wheel, and the effect of that to observe. We also have some ready templates for you guys, which you can easily observe, which you can easily study the behavior of suspension in the way of generally looks like to study the suspension configuration. So what are those default parameters generally we would like to study in any suspension study? We have a template. So once you click on the plot, hypergraph window will pop up. You just need to click on that hypergraph window and say file, open, and then report template, which we have built some ready hypergraph template to build your report in a standard format. So once you load this template in the current parameter value, you just click and load your run file from the directory, which is the PLT file you can load. And then once you load that, just hit apply. It will load the report of your analysis in the format of the template. So how to do that? That also we have explained in the tutorial. So sorry, in the PDF file where you see this half-car suspension guide, which will explain you how to open the model, how to look into the errors of those models, and what is called the graphical area, browser, and panel area, which I have already explained you just now, and then how you can change hard points. Those are also we have mentioned over here. And if, because I'm showing you this PDF to address you where you can refer those entities which will help you to build your model. So I'm showing you in the PDF also, which we have already seen now. And then choosing analysis event, you can activate them. Once you activate any other event, the other event will get deactivated. Even if you want to add some other events which are not considered over here, you can build your own analysis template or analysis events and add those in the model. But most of them are already available, so you should not worry about that. And once we run this model, we do post-processing. Is nothing but to visualize your animation, visualize your results. So which files we have to deal with. So those also we have mentioned here. MRF file, ABF file, PLT, S3D, and SDF. Those are the post-processing files which you can refer to understand the configuration or the reactions of your suspension system. So here I have used this template. So what this template is showing me the steering torque versus time, and there are a couple of standard outputs which you can refer, then roll angle, then displacements, track weight, then your left caster and kingpin inclination and left kingpin inclination angle. So those are all readily available with respect to time, how that is varying with while performing the single wheel analysis. So these are some standard outputs which are readily defined output in the model also. You just need to build the configuration of your vehicle and study these vehicle parameters. You will see the differences of your, if you have kind of set of model configurations like ABC configurations of the vehicle, then you can study those ABC configurations overlying these results over each other and understand which configuration is the better to build the vehicle to get the dynamic performance within the desired expectation. So those can be easily studied over here and perform those comparison study and have a better dynamically good vehicle. And these are again average wheel center, like wheel vertical displacement with respect to the time. So this will be the standard reports template format, which helps you to understand the behavior vehicle. So I'm going a bit fast over here because you can study this down the line later, the offline, once you are performing these events. The idea is to showcase you the capabilities, what you can do and what you can understand to perform the study of your vehicle. So this is what we look for, like force deflections, left parallel wheel lateral force deflection, right, left, right. This symmetric model, so we have this left, right, which you will see. Then force steer, average parallel lateral force on the steer with respect to the time. And you see, you can also click on these outputs to directly you can go to the output which you are interested in. Like if you don't want to go through one by one, so you can browse them in the browser and you can directly go to that output and understand that. So here I have tire patches longitudinal force deflection, so which I can see and observe over here. Also tractive force steer. This is the test rig event, so you won't see those high magnitudes, but once you run this vehicle on the ground or the full vehicle, then definitely you will have some high magnitude forces as well. Right. So this is one of the way to build these templates. And if you don't want to if you want to go back to your original the model file and don't want to have this hypergraph, so you can select these curves in the session. Earlier we were in the plot, so if you go to the session and would like to delete these curves, so you can just select that one and shift and then click on the last one, which will select all, right click and delete. So this way you can delete this loaded report also, and you can study this manually also if you are not interested. If you are sure, if you are doing some initial runs and you don't want to deal with all the outputs, then you can study the respective outputs which you are interested. So for that purpose, you can load your ABF, PLT or MRF, any of the file manually in the hypergraph window, and that you can study. That is also possible. So this I shown you because these templates are built or designed for basically Baha or Supra events, which students don't want to spend much of time to learn a lot of pre-processing and post-processing stuff. So that is where we have added this readily available templates to make easy of you. Okay, so this is one of the configuration of my vehicle which we have seen now. And then if you want to locally understand the some of the outputs, you can definitely easily go to the hypergraph and say marker velocity, marker displacement. So this is kind of a type of your outputs or type of your uh, outputs which you would like to study. Like you would like to study the displacements, velocities, marker forces, expressions. Then Rexup is the default outputs which are user routine based, which are readily available in these templates. And then this is kind of a type what you want to understand, like displacement, velocity, forces. movement, stock. So those all are type of output. Then where you would like to study that, like on the vehicle body or on the upper shackle or lower control arm, wheel or vehicle body, or the reaction forces on the jack, or these are kind of the locations where you would like to observe them. That is called the request. And then once you select this marker displacement and the type where you would like to observe, and then the last thing comes the component. It means the component means whether you would like to see that displacement in x axis, y axis, z axis is called the components. X, Y, Z component or magnitude or any rotational components is nothing but yaw, pitch, roll. In yaw, pitch is roll is nothing but it is again SAE terminology which we use. Yaw is nothing but the rotation about the z axis, pitch is the rotation about y axis, and roll is rotation about longitudinal, which is mean by x axis. So these are the standard terminologies which you will come across to observe the behavior of your system. So this you can study the locally also, and standard report templates which we have seen already. So this is about the front half car model which you can study and build those entities which you can modify. So this is one of the events which we have run, which is a single wheel analysis. If you want to study the kinematics and compliance of your system, that also I have activated that event, and I'll run that event also right away to understand the behavior of that suspension. So these are standard events which we study on the suspension study. If you have any questions at this moment, please type those on the chat box. I will address those because it will take some time to run this event, kinematics and compliance. Okay, we are also providing you the PDF files to understand how to build the full vehicle models as well. These are the templates or the subsystems models which we have designed for students only, but apart from this you can build any kind of configuration of the vehicle through our wizard models, using wizard model approach as well. That will also I'll show you once this KNC simulation. Okay, so this KNC simulation is done. So now I can go to the MotionView and load this, reload the animation file where I can see the kinematics and compliance behavior, where I'm doing parallel wheel travel, opposite wheel travel, and then steering event. So these are types of events we will perform. And plots also, if you reload these PLT files or the ABF files where we just run this model, that also we can observe the behavior of the vehicle within kinematics and compliance. Or if you would like to load the standard report templates, that also again I will show you. If you miss the procedure how to load that standard report template, so that is available in the directory of files which we are providing you. So I'm selecting front half car template, and then once I select that, in the current parameter value you will see the KNC analysis PLT, which is default one. But this is for the any other model which it just show over there. But you run it with your directory, you will have that latest file of your event. You just need to select that file and hit over apply. Once you hit apply, it will load you the results. Okay, so this is the steering output which we are showing in the KNC event. Like if you see first till 80 seconds we have not applied any steering action to the steering wheel, and at the 80 to 90 seconds we are applying a steering angle also, so that you can observe and study over here. Similarly, we have a couple of other outputs, roll angle and track weight, which you can see over the roll angle of that within the while performing this KNC event. So these are standard outputs which you can study. Then you will see here wheel vertical displacement with respect to the time, wheel vertical force with respect to time, toe angle, camber angle, caster angle, pin inclination, scrub radius. So these are all mechanical trail or caster trail. These are very important characteristics of suspension which will help you to understand your system very well. And then these are all the studies which can be carried out in the design stage of vehicle. So once you get the good configuration of the vehicle through the dynamic events, then you can fix your design coordinates and then carry on further analysis of the vehicle and the component levels after extracting the loads from the MBD simulation. So these are the standard outputs which you can easily refer offline also to while performing these events. Okay, so this is what we have performed to understand the suspension behavior in terms of kinematics and compliance simulation. So what we have observed here is the wheel vertical forces, caster camber angle, toe, caster camber toe, caster trail, mechanical trail, as well as the wheel vertical forces, and also we can plot wheel vertical displacement with respect to the wheel forces also. If you want to change any output with respect to the wheel displacement, that also you can change. I'll show you one of them. If my wheel vertical displacement is some X amount, so what amount of force I am expecting? Basically, the force versus displacement diagram. Let me delete all these outputs, the hypergraph files. I will show you how you can plot individually also with respect to the wheel forces or wheel displacement with respect to the force. So whatever the default plots we have, those are with respect to the time. Now if you want to have your X component displacement, then I'll go to the marker displacement, then select the outputs, which is for the wheel center height displacement on left wheel. So I have selected that, and I'll select any Z or DM is the magnitude I can select, and then your Y component would be the marker force, where you would like to understand the left vertical force, like wheel left force, and then that is also I'm seeing. I can see the DZ component. Here, let's say. So this is we are seeing because we have this is combined event of parallel wheel, opposite wheel travel as well as the steering event. So we see this the force output in this fashion. But if we perform if you specify those in the expression bits outputs, then you won't see specifically system is behaving with respect to the or the how the forces you are getting with respect to the vehicle input excitations to the wheel. So this is about performing the suspension events and using these readily available models, modifying them as per your requirements to build your configuration of the vehicle, and then observe the results using standard report templates. So this is about using these models. So if in this case, if you don't want this front SLA suspension, so what I'll do, I'll just deactivate this suspension system, and then we have, if you have any another configuration of system, so what you can do, you can go to the model and say import exports, which we already have some of the systems which are stored in the component customization component folder. Customization folder will be there in the files which we have uploaded on the website. If it is not there, you just contact us. We will provide you these files. In the suspension, I have a push-pull rod, so I have a push rod type suspension which I want to use it. So I'll go to that system and I'll say use this kind of suspension system over here. I'm just going to change the name because those variable and labels are already available. Okay, so this is the way I can import that suspension system in the existing model, and we can have that. And then once you build, bring it, you will see. You just click on that suspension system. You will find some attachment. So these are some attachment tags which are already defined in the model. So using that, you can directly it will automatically read those tags, so you don't need to specify any of the attachment locations over here. It will take care by its own, and then you can run that simulation again. You can cross check is there any errors are there, and then perform that simulation. So this is how you can modify this suspension system with some of the standard systems templates which we have already available. This is about front suspension. Similarly, I can build the rear suspension system. We have already, which we have already have in the set of files which we are sharing with you. So I can just open that model as well to give you an insight over that rear suspension of this system, where there also we have kind of events, so static roll analysis, static ride. So already events of that suspension are already available in the file which you are going to use. There also we have the templates or the data sets where you just need to change your vehicle input parameters and you will have your configuration of the vehicle. Similarly, whatever what I explained you earlier, the same case you have to implement here to build your configuration of the vehicle and build this complete model and perform the simulation. So here we are performing the static roll analysis. Then I'll just run this. I hope you understand these vehicle terminologies which we have used in the model, or these are common terminologies like wheel, knuckle. Those are known terminologies in suspension design. So I'm expecting you are already familiar with those terms. What is lower control arm? What is upper control arm? What is toe? What is rocker and pull rod? So those are very native terminologies in terms of your vehicle events which you perform and which you would like to build for your this Supra events. There we have these bushings. So bushings also very important element over here, where you have to have those bushing properties to be specified correctly. Otherwise, the outputs or the reaction forces which you are observing through the simulation, which will have a consequence or the effect of these bushing values in the simulation. So that might lead you to the wrong predictions of the result. So please make sure that you should have a correct input data, input values to define these bushing stiffness, suspension spring stiffness, preload values, which plays very important role in these vehicle dynamics events. So have those values correctly, otherwise you will see some weird behavior of your system or the vehicle in configuration which you have built. Okay, I guess, yeah, the run is over, so we can observe the uh, behavior of this suspension system. We can observe this, we can see, understand this animation in the HyperView, which is the post processor. Okay, so this is what it will happen when I'm running the static role analysis. So where the objective is to understand the role behavior of the vehicle with respect to the input characteristics of the suspension. For this also, you can load results manually or using template. So for all this, we have readily template available, which you can use rare half-car template also. So we have the three templates over here: front half-car model, which we have seen already. Then we have rear half-car, and also we have for full car also. So I'll select this rear half-car of the vehicle, and I'll select my result, which we have run just now. I'm going to select this PLT, okay. Rear half-car PLT, and then I'm going to hit apply. So it will help to load the results, and then you can predict the behavior and observe the behavior of the model. Okay, so this is what the readily available outputs which you can observe with respect to the time, roll angle, and track width. Because we are doing this static roll, where it is important to understand the roll angle of your suspension system, and also the track width, how it is varying with respect to the excitations given at the wheel contact patch or the wheel center point. Toe in, caster, camber, kingpin inclination, scrub radius. So these are outputs which generally we observe while performing this kind of events. So you don't need to look into how these outputs are created and all. You just need to configure your vehicle input data sets, data points, hard point locations, and just run the simulation and study these parameters, which will save you a lot of time to build this model and understand this modeling part also. So we have make it easy to understand you. You just need to use this. You just need to refer those PDF files or some of the videos which we already have online available to build this model, and you can study the vehicle behavior. So this is about rear suspension. I'll show you. So these are readily available models which we are providing you. But apart from this, if you would like to build any other configuration of the vehicle, which you can build it through our wizard model also. So that I'll show you. Also, I'll show you how to use the full vehicle model. So full vehicle model setup is also there in the uh, directory which we have uploaded. We have seen how to deal with front suspension as well as the rear suspension. Now we will see how to look into the full vehicle model also. So I'm going to have the new session to build the full vehicle model also. So I'm having full car model, but you have to keep that in mind. You should have very accurate input data to design these suspension systems or full vehicle system. Like there are a couple of entities which are very nonlinear. Your spring is has a nonlinear behavior. Your bushings has nonlinear behavior. Your tires, which are very crucial and important parameter, which will give the uh, which will provide the forces, which will generate the forces in the system through the ground contact patch, the tire contact patch. So I have this is full vehicle event model which we have in the model. There also you see we have the bunch of analysis which we have provided uh, in the model file itself. So if we want to perform those events, so you can activate that. So here I want to change, I want to check the straight line single lane change event analysis. So what I'll do, I'll just activate that single lane change analysis event, and the other event will get deactivated. So I can run this model for a single lane change analysis. Okay, I guess there is some issue with this model. So I'll just reload the new model which has from the wizard. So similar model we will build from the wizard. So this is one way to have that model, use that model. The other way is we have this model from assembly wizard. You can build any configuration of the vehicle you want, like front end of vehicle, rear end. This for the suspension, to build the suspension. For full vehicle, I'm going to select the full vehicle option, and then I'll say what type of drive I have here. I'm driving the vehicle with a front wheel, so I'm selecting front wheel drive, and then this is the configuration of the vehicle which I have to select, like what type of front suspension I'm going to have. Front MacPherson suspension I'm going to use, so I'll use MacPherson. What is the steering linkages I'm going to use, so that also I have here rack pin, parallel steering, double idler steering. So appropriately you have to use. If you have any subframe, you can use the subframe also. What type of rear suspension you are using, so you can use that rear suspension also. And what type of tires you are using, so tire also you have to use, and then provide your proper stiffness properties and tire properties to the tire. These are the default tires which we are using here. So this is to refer you how to build those models, how to implement the modeling entities in this model, and you have to replicate these events and the modeling practice in for your vehicle. So this is my analysis, what type of analysis I'm going to perform. So I'm going to perform single lane change analysis here. So I have added that analysis event also. So we'll perform single lane change. This is again single lane change data. What is the vehicle velocity? What is the cone spacing? Like and then finish this. Then go to the run panel. first save this model and run it. Because someone had some doubt. If you have any doubt, you can write down that in chat box. Someone has raised the hand. So if you have any questions, you can write them in the question box or send us an email. We will address them. Okay, so I'm done with this event. The single lane change event, which we were trying to perform. So that analysis is over. I'll use my analysis and some standard outputs report also. There also we have standard reports which we are going to use. I'll say okay. So which will load the standard outputs which we mainly look for the single lane change analysis. Those are lateral accelerations versus time, yaw rate of the vehicle, then steering wheel angle, then vehicle CG displacement with while moving the vehicle on the ground, the roll angle, then steering wheel torque versus time. So these are the some standard outputs which we would like to observe while performing. And then apart from this, definitely we would like to see how the vehicle is performing on the ground. So that also we observe over here. So this is my vehicle which is performing the single lane change analysis, which you can see. I'll just change this view. From the top view also you can see how the vehicle is moving. I guess I'll just slow down that animation so you can observe the vehicle behavior. So it will go straight for some time and then take turn and then again take a turn. So that is the scenario for a single lane change. Similarly, if we have a double lane change, then it will take the turn twice and then carry on a straight line further again. So this is the event which we perform for the full vehicle. There are a couple of other events also. I'll just delete these standard reports and we'll go to the model single lane change which we have performed. If you want to add on top of this, if you want to add another analysis event, you can add that double lane change, constant radius, throttle off cornering analysis, brake, sinusoidal steering, J-turn, step steer analysis, pulse steer. So those are all the analysis events which we perform with the full vehicle events. So these are the models which you can build apart from the models which we are providing you in the standard model files which we are sharing with you. So, okay, so here I am running now J-turn analysis. We'll see how the we'll observe the behavior of the vehicle in this event, and we'll observe some standard outputs of this J-turn event as well. The significance of this on the vehicle, we can observe this virtually, and then we can understand that physically also on the ground, proving ground test. Okay, so my J-turn event analysis is also done. I'll go to the analysis. I'll see view reports, standard report template. I'll load the report also. Okay, so this is my standard report templates, which shows me the vertical tire forces versus lateral acceleration. It shows me front axle load versus lateral acceleration. Then steering wheel angle versus the lateral acceleration, which is important to understand the vehicle behavior, which we are seeing the sudden turn of the vehicle. Okay, we'll observe the vehicle animation also. So this is how we can perform these simulations to understand the vehicle behavior, to understand suspension behavior. I know there are a lot of entities which needs to be addressed very effectively in the model. So while performing that, if you find any issue while defining them, those entities are the performing those simulation events. If you find difficulty, you can always reply back us. We will answer them and then help you to perform those events. So on MotionView, MotionSolve front to perform vehicle dynamics modeling, I have I explain you the things how to perform those events to suspension analysis and the significance of the suspension analysis. Also, we are providing you the PDF files to understand the dynamic of the system, the system to understand the dynamic of the your suspension vehicle. Still, apart from that, if you find any difficulty, you can send us emails. We will address them. So this is what I have for today's session. So we'll keep this session on for another 5 minutes. If you have any queries, you can write questions in your chat box. Otherwise, we will end this session after 5 minutes. So thank you all for attending the session, and hopefully I